Let's now talk about how we can construct a relation. So what's really a relation? Relation is a very general concept that can be used to really specify a computer system, as we will see throughout the course. So a relation, intuitively, is simply a set of mappings, right? Each mapping is simply going to be an order pair or a two, or like a tuple of size 2. It's going to be an order pair that maps a member of a set S to another member of set T. So basically, we are thinking about how S and T can be related to each other, right? That's a relation. For example, let's say one set is actually 1, 2, 3, and the other set is actually AB. Let's say we got these two sets, and we want to construct some relation between these two sets, right? Intuitively, a relation is going to be a set, right? It's going to be a set of pairs. Each pair is going to draw the first element from either of the three elements over here, and the second element in the pair is going to draw from either one of these two elements here, right? Intuitively. This is very interesting facts to know. Whenever you want to define a relation between two sets, we can say that empty set is always a valid relation between any two sets, because you can think about, by definition, a relation is simply a set of mappings. In that case, the set itself is just empty, meaning that we are talking about a very special relation in which there are simply no elements being drawn from the two sets, so it's empty by definition. Okay, and here S cross product T, right? Remember we talked about cross product just in the earlier slides, and S cross product T can give you the maximum relation between S and T, right? Let's say here we got 1, 2, 3, and also we got AB. If we try to do the cross product S times T, what will be the cardinality of the cross products? Well, as we talked about before, the first every element in the cross product is going to be a pair where the first element will be drawn from the first set, and the second element will be drawn from the second set. So now how many possibilities? There are 3 possible ways to choose the first element, and 2 possible ways to choose the second element. So we got 3 times 2. So we got exactly 6 over here, right? If you try to look at that more closely, either the first element is actually 1, or the second element, let me say it again. Either the first element is 1, or the first element is 2, or the first element is 3. In the case where the first element is 1, the second element can either be A or B, right? Over here. When the first element is actually 2, the second element can either be A or B, right? You can see the general pattern, some very sensible pattern over here in constructing the maximum relation being the cross products, right? And then this is just another example relation over here, okay? So now we're just using the set comprehension notation. We're saying that, well, think about relation is simply more like a synonym to a set of pairs, okay? So here we're saying that this is a set. Using the set comprehension notation, every member in the set is an order pair XY, where, first of all, XY is actually a member of cross product between S and T, which means XY can either be this, or this, or this. So there are 6 possibilities for X and Y. However, we are restricting that using conjunction by saying that the first elements, X, cannot be 1. So that means we're discarding these 2. So the resulting relation would just be this part over here, right? So that's just one way to actually specify what a relation should be. Hopefully you can see the idea. All right, so far it's rather straightforward, so I don't need to illustrate anything to you, but I'm going to definitely do some exercise together with you on the paper in a moment. All right, hopefully so far so good. But the most important idea for you to, let me recap quickly. A relation, whenever we talk about it, it boils down into simply a set of order pairs of size 2. Okay, and whenever we talk about the relation between two sets, in that case, there is always there are always 2 special relations between two sets. The empty set is the smallest relation that you can draw. You can actually derive between two sets, the smallest relation. It's pretty much like the empty set is always the smallest subset that will be included in the power set of some set. That's kind of analogous. And the second special relation is here. The cross products between the two sets will be the maximum relation between them. Okay, this will be analogous to the set itself will be the maximum subset in the power set, right? Similar idea. Okay, well, so if you really get it, I'll suggest you also write down what I just said. I think that's why I'm recording the lectures slowly, so you can also take notes on your own. All right, having said about the the two special relations, and also you can get somewhere in between. Now we want to really know, is there any systematic way to really figure out all the possible relations between S and T, right? So here we only talk about 3 examples in relations between S and T. The smallest relation, the maximum relation, and also somewhere in between. Can we actually enumerate all the relations? Is it possible? Indeed, but we're going to see how to do it. Okay, let me talk about one more slide, and then we're gonna do one exercise together. Okay, so we use the power set operator to really express the set of all possible relations. That's exactly actually what I just mentioned, but we're gonna do exercise for sure. Okay, in order for you to figure out all the possible relations, which means it's gonna be a set of sets, right? It's gonna be a set where each member is simply just a relation being a set of pairs. Okay, this is the notation, right? I think consider this very carefully. I know up to this point it might get a little bit confusing, but that's okay. I think that's why you have to study the topic more carefully, right? We started with talking about power set earlier, and we talked about the cross products separately, and now we're putting these two things together, and these two things tells you exactly the set of all possible relations between two sets. That's really something you want to appreciate and really understand. Okay, so each member in this particular power set is going to be a subset of this cross product over here, and a subset of the cross product. For example, a subset of this particular cross product can be a set that contains only these two pairs. In that case, that particular set is just a relation, right? But we're going to do example together, don't worry. Okay, so each member in the power set of S cross T is going to be just a relation, being a set of pairs, a set of tuples. And let's now talk a little bit more about something you will see later. So what about whenever you want to declare some variable, you want to say that variable can hold the value of a single relation, right? So that's what we have over here. Think about some analogy over here. I want you to see. Okay, so whenever we say I, let's talk about something you're familiar with back in the Java course, right? So here, whenever you say integer I, that's how you declare in Java, right? So you're saying at a runtime over here, I can store a single integer. Agree? I stores a single integer. Not multiple, just one single integer at a time. And this is so-called the type of I. And the type is usually a set of possible values that a variable can really have. So simply a set of 2 to the power 32, right? Remember, it's 32 bits for the int in Java. Set of 2 to the power 32 values. Right, we're saying that at the runtime, I can store any of these values, only a single one, right? That's the insight into how we declare them. So another way for you to think about it is, this is how a declaration could be formalized. We say I is simply a member of integer. All right, having this in mind, let's now take a look at what we meant by this. Okay. Let's say, of course, as we'll see later, we're going to use the colon over here in the ASCII character to actually say is a member of. Okay. Let's now talk about this part over here. Okay. So what does it really mean when we say R is a member of the power set? Right? We're trying to declare. Okay. So let's now try to look at this one aside. Let's say R is a relation. We're saying that it is of type the power set of S cross product T. Okay. Let's now take a look at this. S cross product T over here, as we learned before, is the maximum relation on S and T, right? That's a maximum. It's a single relation. But now we are talking about to take the power set of the maximum one, right? Each member is a subset of S cross product T, which is a maximum relation, which will be a smaller relation. Oh, you know what? Let me be a little bit more precise. So every each member over here is going to be a subset of the maximum relation, right? And the maximum relation is simply a set of tuples, and then we're saying that it's a subset of that, right? Right, and which will be a relation smaller than or equal to S cross product T. And we'll see exactly what it meant. I just want to annotate this first. Okay, so knowing that power set is simply going to be a set of sets, and each member is simply a set of pairs, and then it's simply a subset of the maximum relation, right? Hopefully so far you're still kind of following me. And then we are saying that R is simply just a member of this power set, meaning that it can be just any of the member, just a single member. Okay, let me just write this down, and then we'll move on to some example. So the R over here, we are saying that declare to store the value of a single relation, which is a subset of S cross product T. Try to maybe once we have done the exercise, that you will feel a little bit better about what's going on. But I would suggest try to read through. Try to also read through the comments I actually made over here. I think I put in there actually for a reason, just to help you understand what's going on over here. So you really want to understand the notation over here. All right. All right. Let's now go back. Alternatively, what we can we have some synonym to this notation here, since we may have to use this kind of idea so often to really characterize the set of possible relations between S and T. So rather than just writing a power set, so this is a new notation. I'm pretty sure you've seen this before. So we say S, and then it's a double-headed arrow over here, and then between T, right? Between S and T. So this over here is synonymous with to the power set notation. So they are meaning the same. They're referring to the same thing. Both of these simply refer to the set of all possible relations between S and T, right? Over here. Okay. So you want to know about quite a few things over here in these slides. First of all, understand exactly what this means. Understand what it means when we say R is a member of this particular power set, and also understand that this is the new notation about about specifying the set of relations between S and T over here, right? Okay. So what we are saying is, when you declare R is a member of the power set of S cross product T, so that's really equivalent to R is a member of S related to T, right? So these two notations are completely equivalent to each other. Okay, this one here and also this one here, they really mean the same thing. All right.